consider this problem statement. We need to compute the number of real solutions for the given equation. So the equation is given as e to the power 4x plus 8 times e to the power 3x plus 13 times e to the power 2x minus 8 times e to the power x plus 1, that is equal to 0. So now let us proceed towards the solution part. So first of all, I will replicate the equation as it is, and to simplify this and proceed ahead, I will consider an assumption, that is, I'll take this e to the power x as t, so that the equation gets simplified up to large extent, right? So this can be written as t to the power 4, e to the power 3x can be written as t cubed, e to the power 2x can be written as t square, and e to the power x can be written as t. Now, proceeding to the next step, so what I will do here, I will take t square common. I'll take t square as the common factor and divide on both the sides, right? Later, in the later stage. So this will be t square plus 8 times t minus, this will be 13 as it is, and here, so this will be plus 13 minus 8 over t, 8 over t plus 1 over t square, that is equal to 0. Now since t square is a positive quantity, so if t square, if this e power x is positive, then definitely t square is also positive. So we can divide on both the sides, and this one can be written as equal to 0, right? Now if you observe here, this if I just rearrange the terms little bit, that is this t square and then this plus 1 by t square, and from this 8 over t and this 8 t, I can take 8 common, right? So here I'll just rearrange the terms little bit. So replicate this. So this plus 1 over t square, I'll write it over here, and then this 8 and this one, I'll write it over here. 8 is the common factor here, right? So this will be 1 over t and 8 will be written outside, right? So we can rearrange and write in this way. Now if you observe this quantity, so this is nothing but a square plus b square, so this can be replaced, right? This one I can use an identity for this one. So instead of this one I can write this one as t minus 1 by t whole squared plus 2, right? So this will be t minus 1 by t whole squared plus 2. So this is the replacement for this given expression, sub expression, right? Now proceeding ahead, so here t minus 1 by 1 over t is repeated here, right? And this is a quadratic, this is the part of the quadratic family, it appears in that way, right? So what I'll do, I will make another assumption here. Let z assignment this one, that is t minus 1 over t. So this ultimately converts to a quadratic format that is visible to us. So this can be written as z square plus 8 times z plus 13 plus 2 is 15, that is equal to 0. On factorizing this, this turns out to be z plus 3 times z plus 5, that is equal to 0. So that means clearly z can take the value, that is negative 3 and then negative 5 and negative 3, right? So now we'll cross check this one, we'll back substitute this value of z with this expression, right? So now in the next step we can say, that is t minus 1 over t, that is this one. In this assumption I'll substitute z as, first of all, with negative 3. So this one, if you observe, this one can be written with negative 3 and this can be written with this positive 3. So from this one, for this one we can write that this one will be equal to negative 3, or one more thing that can be written is z is equal to this one. For this one again we can write for this one as negative 5. This is repeated here, let me just remove this. So negative 5 and negative 3. So from this one, if I solve this quadratic, if I solve this quadratic part and this quadratic part, right? So this will further imply that t will belong to these four roots, right? So for the first one, this will be minus 3, positive and negative both, square root of 13 over 2. And in the next one, this will be negative 5, positive and negative both, square root of 29 over 2. So these are the four roots with positive and negative, right? So from this one we can say, here it is given that t is equal to e to the power x. So from this and so we can say that, so we can definitely say that t has to be greater than 0. T has to be greater than 0. So only the positive quantities are the ones which we can consider. That means this one, minus 3 minus square root of 13, that has to be rejected. And then so because of this positive, so we can clearly say that t has to take these values. So these negatives will be eliminated. The negatives will be eliminated. So this would be square root of 13 minus 3 over 2, and this will be square root of 29 minus 5 over 2. So these are the acceptable values. So finally we can say that this t, which was assumed as e to the power x, so e to the power x can accept only these two values, right? So there are only two roots for this one. So finally we can say that answer is 2. So there are only two real solutions are there which will satisfy this given equation, right? And if you have to isolate x, we can take natural log of e, right? So if I write e to the power x is equal to this, so I can take natural log of e, ultimately x can be extracted out. But anyways, we need not compute the value of x, we need to find the number of real solution, and the answer is 2.